On February 15th, 2013, hundreds of dashboard cameras across Chelyabinsk, Russia, captured something that should not have been possible. A fireball, brighter than the sun, tearing across the morning sky at 42,000 miles per hour. Pedestrians stopped dead in their tracks, staring upward at something nobody could explain. Nothing like this had happened over a major city in recorded history. Within minutes, windows across thousands of buildings would shatter. 1,500 people would be injured. And every space agency on Earth would have to answer an uncomfortable question. How did a 20-meter asteroid sneak past every telescope, every satellite, and every detection system we have without anyone noticing? This is the Chelyabinsk event, the day the universe reminded us of just how exposed we really are. So what exactly hit Chelyabinsk that morning? It was a near-Earth asteroid, a chunk of rock that had been silently orbiting the sun for millions of years without anyone knowing it existed. We didn't have it in any catalog. We weren't tracking it. As far as humanity was concerned, this object simply wasn't there. 20 meters across and roughly the size of a 6-story building. On the cosmic scale, this thing was a pebble, the kind of debris that fills our solar system by the billions. Insignificant and unremarkable. But take that pebble and accelerate it to 42,000 miles per hour, and it transforms into something else entirely. The asteroid entered Earth's atmosphere at a shallow angle, approaching from the direction of the sun. That single detail explains everything about why we never saw it coming. Every telescope we have points away from the sun, because you cannot observe anything hidden in the glare of our own star. Trying to spot this asteroid before it hit would be like trying to see a mosquito flying directly in front of a floodlight while the light is shining in your eyes. So, this rock, this cosmic intruder, passed through every defense we had without triggering a single alarm anywhere on Earth. No warning, no evacuation, no time to react. And then, physics took over. At 9:20 a.m. local time, the asteroid slammed into the upper atmosphere at 19 kilometers per second. At those speeds, air doesn't behave like air anymore. It cannot move out of the way fast enough, so it compresses violently in front of the object, creating immense pressure and heat. The surface of the asteroid began to glow, then melt, then vaporize completely. The entire rock transformed into a superheated fireball, screaming across the sky at hypersonic speed. For roughly 30 seconds, this blazing meteor lit up the entire region, visible from hundreds of miles away. It was brighter than the sun itself, casting sharp shadows across the snow, even though it was already broad daylight. The dashcam footage from those 30 seconds is surreal. You can watch the sky turn white as cameras struggle to adjust. Drivers slow down, trying to process the impossible brightness flooding through their windshields. There's footage from inside schools where children watch the streak with a mixture of wonder and fear. Most people probably didn't understand what they were looking at, because most people had never seen anything like it. Then, at roughly between 25 and 30 kilometers above the city center, the meteor could no longer withstand the pressure. It exploded. The airburst released energy equivalent to roughly 500 kilotons of TNT, about 30 times more powerful than the atomic bomb dropped on Hiroshima. But this was not a nuclear weapon. There was no radiation, no mushroom cloud, no fireball hitting the ground. This was a purely kinetic event, an object carrying so much speed and mass that the moment it shattered, all that stored energy released simultaneously in a single catastrophic detonation. The shockwave rippled outward in all directions. But here's the thing about shockwaves. They travel slowly compared to light. Everyone in Chelyabinsk saw the fireball first. They watched the glowing streak cross the sky. They saw the blinding flash of the explosion high in the atmosphere. They saw the twisting smoke trail hanging in the air like a scar. And then, there was silence. For 2.5 minutes, nothing happened. The explosion was over. The sky was clearing. People started emerging from buildings and cars, craning their necks upward, trying to make sense of what they had just witnessed. They pulled out their phones and called friends and family. They posted videos to social media with confused captions. Some thought it was a plane crash. Others assumed it was a military exercise or a missile test gone wrong. A few people, perhaps remembering old Cold War drills their parents or grandparents had taught them, quietly moved away from windows. Most did not. 2.5 minutes after the flash, the shockwave finally arrived. It hit Chelyabinsk like an invisible wall, moving at the speed of sound. Windows exploded inward across more than 7,000 buildings simultaneously. Entire apartment complexes had every pane of glass blown into living rooms and bedrooms where people had been standing moments earlier, watching the sky. Schools, offices, hospitals, homes. The sound was deafening, a roar that rattled bones and shook buildings to their foundations. A zinc factory near the blast zone had a section of its roof collapse from the pressure wave alone. The footage from this moment is genuinely haunting. You can watch videos where people are calmly filming the smoke trail above them and commenting on how strange and beautiful it looks. Their voices are relaxed, curious even. Then, without any warning, the windows behind them detonate. The camera shakes violently. Over 1,500 people were injured in the span of a few seconds. The vast majority of injuries came from flying glass, deep cuts, severe lacerations, shards embedded in faces and arms and backs. Some required surgery. A teacher in one school threw herself over her students when the shockwave hit, shielding them with her own body and taking glass fragments across her back and shoulders. A woman near the zinc factory suffered a broken spine from the blast impact. Workers inside were caught when the roof gave way above them. Miraculously, nobody died. But that outcome was pure luck. The explosion occurred high enough in the atmosphere that the shockwave had weakened significantly before reaching ground level. If the asteroid had been slightly larger, or if it had entered at a steeper angle and penetrated deeper before detonating, we would not be talking about injuries. We would be talking about mass casualties. The universe left one final piece of evidence behind, a fragment of the asteroid, the largest piece to survive the explosion, punched straight through the frozen surface of Lake Chebarkul, about 70 kilometers from the city center. It left a nearly perfect 6-meter hole in the ice, a dark circle surrounded by white, like a bullet hole through a frozen shield. Divers spent months searching the dark and frigid water at the bottom of that lake. Eventually, they found it. A 650-kilogram chunk of the meteorite resting on the lake bed, the rock that nearly killed a city, pulled from the depths and now sitting in a museum where anyone can see it. Proof that this actually happened. Now let's talk about what almost happened. The nightmare that didn't quite arrive. What if the Chelyabinsk asteroid had been 50 meters wide instead of 20? That's still microscopic by cosmic standards and still completely undetectable with current technology. But those extra 30 meters change everything. A 50-meter asteroid that penetrates deep enough to impact the ground doesn't shatter windows. It erases the city beneath it with an explosion in the megaton range. It'll create a crater hundreds of meters wide and dozens of meters deep. Everything within several kilometers gets vaporized so quickly that no one would even have time to feel pain. But let's forget Chelyabinsk for a moment and consider geography. What if this exact event, a 20-meter asteroid coming in from the sun's direction at 42,000 miles per hour, with zero warning, happened over a different city? Chelyabinsk has roughly 1.2 million people. Tokyo has 37 million, packed into a much denser urban area. The same shockwave, the same exploding glass. But instead of 1,500 injuries, you could be looking at tens of thousands, possibly hundreds of thousands. Hospitals overwhelmed within minutes. Transportation paralyzed. Emergency services unable to reach the wounded through streets covered in debris and crushed vehicles. And here's the part that should unsettle you. We would not see it coming. Even now, over a decade after Chelyabinsk, our asteroid detection systems remain focused primarily on the large objects, the planet killers, the dinosaur extinction-sized rocks that could end civilization in a single blow. We scan for asteroids over 140 meters in diameter because those are the threats that keep planetary defense scientists awake at night. But Chelyabinsk was only 20 meters. Millions of asteroids that size are drifting through the solar system right now. We have cataloged a tiny fraction of them. The rest remain invisible to us because they are small and dark and often approaching from the direction of the sun, hidden in the same blind spot that let the Chelyabinsk rock slip through. Right now, at this exact moment, there could be a 20 or 30 or 50 meter asteroid on a collision course with Earth, and we will not know until it enters the atmosphere. The Chelyabinsk event was a wake-up call that the scientific community actually heard. After February 2013, the conversation about planetary defense shifted. Governments and space agencies around the world had to acknowledge an uncomfortable truth. You don't need a planet killer to cause mass casualties. You just need a small rock, bad luck, and a populated area beneath the impact zone. Since then, there has been a serious push to close the gaps in our detection capabilities. NASA's NEO Surveyor mission, planned for launch in the late 2020s, is specifically designed to spot asteroids approaching from the direction of the sun, the exact blind spot that made Chelyabinsk possible. There's also DART, NASA's Double Asteroid Redirection Test, which successfully altered the orbit of an asteroid moon in 2022. We proved that if we see something coming with enough advance warning, we might be able to nudge it off course before it reaches us. But those solutions only work with time. Chelyabinsk gave us none. The asteroid was not detected until after it had already exploded above the city. If it had been larger or aimed more directly, no amount of technology would have saved anyone. There would have been nothing to do except watch the sky catch fire. And this wasn't even a freak occurrence. In 1908, a similar airburst happened over Tunguska in Siberia, flattening more than 2,000 square kilometers of forest. Trees knocked down in a radial pattern, stretching for miles in every direction. The only reason nobody died was because the blast occurred over empty wilderness instead of a populated area. Two major cosmic airbursts hitting the same country 105 years apart isn't strange luck. It's simple statistics. Russia covers more of Earth's surface than any other nation. It will always catch more than its share. We got lucky in 2013. A city of over 1 million people took a direct hit from a cosmic bullet and walked away with injuries instead of funerals. The glass shattered, but the building stood. The wounded bled, but they survived. But luck like that doesn't last forever. The universe is filled with these rocks. They are everywhere, orbiting silently in the dark, following paths laid down billions of years ago when the solar system was young. Most of them will miss us by millions of miles. Some will pass close enough to see with backyard telescopes. And eventually, inevitably, one will not miss. The only question is where it will hit. February 15th, 2013 should have been an ordinary Friday. People driving to work, kids sitting in classrooms, and factory workers clocking in for their shifts. Nobody in Chelyabinsk woke up that morning expecting the sky to explode above them. But that is the nature of the universe. It doesn't send warnings, and it has no interest in our schedules or plans or the coffee we hadn't quite finished yet. Chelyabinsk learned that lesson in the span of 30 seconds. A flash of light, a few minutes of confused silence, and then a shockwave that turned ordinary windows into weapons. We have the footage. Hundreds of cameras captured the moment an entire city discovered just how thin the barrier between normal life and catastrophe really is. We have the data, the scientific analysis, the fragments pulled from the bottom of a frozen lake. We know exactly what happened, and exactly how close it came to being so much worse. And we know with absolute certainty that it will happen again, somewhere on this planet, on a day that will begin just as ordinary as that Friday morning in Russia. The only uncertainty is whether we will see it coming, or whether the first warning will be the light. If this changed how you look at the sky above you, subscribe. There is a lot more out there that you probably haven't heard about yet. See you in the next one.